All right, guys, so we're going to go on and get started with the notes today. What we're talking about today are matrices, specifically augmented matrices. Now, a matrix itself is a rectangular arrangement of numbers. Each number in a matrix is called an element. It's an element of that matrix. Now, a matrix has dimensions, rows by columns. So number of rows by the number of columns. And we write by with an X. Thank you. So this one here, matrix A, has 2 rows and 3 columns. So we call it a 2 by 3 for its dimensions. So when we take a system of equations and write it as a matrix, it's called an augmented matrix for that system. Now we're going to look at this here, and we're going to write this set of equations as an augmented matrix. Battery's dead?
Yeah.
I'll take it. Because, yep. Now with these calculators here, if they start saying low battery, cool. Keep using it till it won't turn on. Mainly because each one of these takes 4 AAA batteries.
Well, if they're AA, I'd have some hot
Yeah. And we normally go through at least 100 AAA batteries a year. So
goodness gracious.
just to save, make sure we're not just spending excess cash, we're going to run the batteries till they are absolutely dead before having to replace them. But luckily, I did pick up enough batteries for the year, so we should be good there. Huh? No. All right, guys, so if we look at this first one here, we need to write it as an augmented matrix. We need all the variables on the left side of each equation, the numbers without a variable on the right. So these 2 equations, we do have both variables on the left, numbers on the right, yes? Now the variables have to be in standard form. All that means is it's X, then Y, and then Z if we have it. They need to be in alphabetical order. Now if we look at the first equation, the X and Y are switched. So we just need to flip these 2. Because they're on the same side, we can rewrite it. We would put the X first. So we'd have negative 2x plus y is equal to 1. Since the x and y are already on the same side, we can switch the order. Okay? Questions on this here so far? All right. Now when we write this augmented matrix, we take the coefficients, the number in front of each variable. So the number in front of x is negative 2. The number in front of y is 1. And then we put the number that it's equal to, which is 1. So our first row is negative 2, 1, 1. Are you ready for the second row? So if we look at the second equation, the number in front of x is 1. Number in front of y is 3. And it's equal to 12. So we've now written the augmented matrix. Now we need to state the dimensions. So it's going to be the number of rows, and we have how many rows? 2. By the number of columns, and we have 3. So the dimensions for this matrix are a 2 by 3. You don't necessarily have to write the numbers out next to the matrices to the left and below it. I'm putting that there so we can count and visually see rows by columns. Questions on this here? That's it. We answered this problem. Yeah. We're ready for the next one. Let's look at this one here. 3y plus 4x equals 13, and 2x minus y equals 5. So the top one, we do have to switch the x and y, giving us 4x plus 3y equals 13. The second equation, 2x minus y equals 5, is fine as is. So what would be our numbers for the first row? 4, 3, 13. Second row, 2, negative 1, 5. Yes, because we take the sign with it. Now looking at this here, how many rows do we have? 2. How many columns do we have? So the dimensions are 2 by 3. Questions on this here? So let's look at this one here. So this one here, if we look at the middle equation, we have x and y, yes? They're both on the left-hand side. They're in alphabetical order, and the number without a variable is on the right-hand side of that equal sign, yes? Third equation has x, y, z. They are in the correct order because x is first, y is second, z is third, and it's equal a number. We're good there, yes?
So the top be minus, it would be 4y minus 6z, right?
Yes, almost. Because we can't say minus 2z, because here, the 2z is on the right-hand side of that equal sign, yes? So if we want to move it from one side to the other, we've either got to add it to both sides or subtract. So we'll have to add 2z to both sides. Because negative 2z plus 2z is 0. On the left-hand side, we'll have the 3x minus 4y plus 2z. Because to move stuff from one side of the equal sign to the other, we've got to add it to both sides, subtract it to both sides. Because the big difference between it and the problems we've done before, or the ones we did earlier, is that those variables are on the same side of the equal sign. So we can rearrange them however we want. But if we got to move something across an equal sign, we've got to do either addition or subtraction. So our new top equation, 3x minus 4y plus 2z is equal to 7. So if we wrote this augmented matrix, the first equation would be what? 3, negative 4, 2, 7, yes? The second equation's numbers would be 9, 3, 0, 3. And the last one, 2, 4, negative 1, 2. Now 0 is correct for the z value in that second equation. Because there is no value of z, there is no z written, so its value is understood to be 0. The biggest thing I would say with this here to know when to put it and when not is if you look at the other equations and they have that variable, the rest need it too. Because the top and bottom both had z, the middle has to have z as well. Even if only one of the equations, the top one was just xy, the middle one was just xy, the bottom one was z, all three need z. If one of the equations has it, the rest have to have it as well. Because even if we look back at the one before, these here only are in xy. There is no z. We do not list it. Because it's not included in one of them, we don't list it. And the dimensions would be 3 rows by 4 columns. So 3 by 4. Questions on this here? We have this one here, are all 3 equations written in the correct form? XYZ, 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 number. So we can go on and just write it. We have what? 8, negative 3, 1, 5. 1, 4, 2, 9, -7, -3, -6. And this is a 3 by 4. That's the same problem. Do we need to see another example of writing an augmented matrix? Okay. We will move on. Solving systems of equations using technology. Now, we're going to use the calculator to solve a system of equations. Now, before we do that, I'm going to look at this augmented matrix that they gave us here. Now, when we wrote it out, we put x in the first column, y in the second, z in the third, and then the number that it was equal to in our fourth column, yes? So if we wrote it back out, this first row is saying that we have 1x plus 0y plus 0z is equal to -1.4, yes? Do we normally write 0y and 0z? No, so what is this really telling us? X is equal to -1.4. Similarly, with the second row, it's telling us really that y is equal to 5.2. And in the last row, z is 16. So if we can get it in this form here, with this diagonal of zeros, we know what x, y, and z are. And specifically, if we wrote it for this here, the solution would be the point -1.4, 5.2, 16. Could be our solution, yes? So, that's what we're going to be doing. Now, this diagonal of zeros, this here, what we call this is reduced row echelon form. Reduced row echelon form. Okay? 4 main steps. You do have this in your notes. We want to write an augmented matrix. We want to enter it into the calculator, use reduced row echelon form, and then interpret the solution. So on this page here where you see the 4 calculator pictures at the bottom of the page, yes? The problem's right there. It's very hard to see. Yep. We see it right there. So that's the problem we're going to do here. Now the first thing we need to do is write the augmented matrix. Now this is already in the right form. 1, x, y, z, all the way across. So our first set of numbers would be 1, 1, 1, 2. Then we'd have 2, 3, 3. And lastly, 1, -1, -2, -6. And it is indeed a 3 by 4, yes? All right. Turn the graphing calculator on. Okay. Clear that out. Clear this out. So one of the nice things with the graphing calculator and the 30XS is down here at the bottom where it says key press history, so it will log everything I type in. Also, where we do have the big calculator on the left-hand side, whatever button I hit last will actually be highlighted red. So the first thing we're going to do is we're going to go second matrix. Second matrix. Second x1. So the blue button, second, and then that x to the -1. And you should get a screen that looks something like this here. Now you might have numbers, so dimensions next to A, B, C, D, E, F, G, H, I. That's fine. All that means is, so for my calculator, matrices 1 through 4, there's been a matrix put in place of it. So there, I have actually set or defined what matrices A through D are for my calculator. That's fine. Doesn't really matter. What we're going to do is go over to edit. So you're going to use the right arrow, go over to, and we're at edit. What edit does is let us put numbers in or define these matrices so we can do things to them. For our case and purposes, we'll hit enter for matrix A. Now, the first thing it's going to want us to do is to define the dimensions. Well, the matrix we want to put in is a 3 by 4. What you can do is hit type 3, enter, 4, enter. I hit enter after I finish typing each number, because if you notice each time you hit enter, it moves it to the next location. So the first row is supposed to be 1, 1, 1, 2, yes? So we can type 1, enter, 1, enter, 1, enter, 2. And then 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. Now, if you type the minus sign instead of the negative sign, it will throw an error. You have to use the negative button, not the minus. Now, y'all's calculators will not show this entire matrix as a whole. So it'll show you 3 by 3, and it'll scroll over to the 4th column. Everybody been able to type this whole thing in? If not, let me know, because, again, it is a lot of steps, but once we see how this works and get used to it, it's going to be nice. We get them all typed in. Second, quit. Second mode. So some of them had it already typed in from previous hours. Second, quit. Second mode. Yep. So what we did is we quit out of that, because if we try to do anything after this, it's going to try to put that into the matrix because we're still editing, putting things in. So it is possible to put other functions, other things in to it. So we want to quit out of edit. We want to go back here. Second matrix again. But this time we're going to go over to math. The second set of options. These are all different things we can do with matrices, different operations we can do with matrices in these calculators. Now, what we're looking for is reduced row echelon form, RREF. So scroll up or down and find RREF. Once you find it, hit enter. RREF. And you should get something like this here. Now, what this is telling us, and the calculator is waiting for, so RREF, it's going to tell it to put a matrix into reduced row echelon form. But at this point, we don't have a matrix after it. We've got to tell it which matrix to apply this to. So the last thing we need to do is go back second matrix one more time. And this first list of matrices lets us recall it. Now we put this in matrix A. So we'll hit enter. So you should have RREF parentheses A. Yes? Hit enter one more time. And we got something that looks like this here, yes? We get those exact numbers. So, going top to bottom, in that last column, negative 1, 1, 2, it's telling us that x is negative 1, y is 1, and z is 2. Or that the solution to the system of equation is the point negative 1, 1, 2. That's it. So that last column that you have is the solution. X is on top, y is in the middle, z is on bottom. And to answer the question, yes, everything we did in 1.5, solving those by him, that's what the calculator just did. It solved that for us. Yep. All right, let's look at this one here. 2, 3, negative, so first thing we want to do is write this matrix C as an augmented matrix. So the first row would be what? 2, 3, -1, 15. Our second row would be 3, -9, 9, -12. And our last one would be 4, -3, -1, 19. And this is a 3 by 4. Once we get that set up, we'll turn the calculator on. Go back to the calculator. Second matrix. Second matrix. And we're going to go over to edit. Now at this point here, unless we're using more than one matrice, we're using 2, 3, 4, we would use A, B, C, D. We'd use multiple. At this point here, let's just keep putting it back in for A, back in for the first one, because we're only using one. And it is still a 3 by 4. Now we're going to enter this matrix in. Now the first so many times you do it, it's going to take you a bit to get used to typing them in. But it is helpful to get the hang of this. I will also tell you this, these graphing calculators are allowed on the ACT. So you can actually use these on the ACT. So if y'all remember the pre-ACT or the test that we took at the end of last year where it asked you solve which of the following equations intersects at this point, we can do that. Looks like it. We'll see here in a second. Or add the two matrices together. As we see here, we can do matrix operations. We can do a lot of stuff with these things. So we will be using these here. Now, once everybody, you got them typed in, second mode. Now we need the RREF, so we can go second matrix, over to math, and we want to find RREF. We got that there, and then we hit enter. So select go to. So what it's saying is there's no matrix at this point after it. So you need to, so before you hit enter, so we have this here, yes? Now, so if you don't have a matrix put after it, it's not going to have anything to do with it. So the last thing we have to do is second matrix one more time and recall matrix A. Because if you just have the RREF but no matrix after it, selected after it, it won't work. Does that make sense? Yep. Because it's going to give you an error if you don't have a matrix after the RREF. Is it saying you wanted to do this reduced row epsilon form on a matrix, but you did not tell me what matrix to do it to. And our solution is what? 5, 1, -2. Questions on this here? Question on anything we've done so far? Now I do know we have 2 problems left. We can easily finish this today, but with